Welcome to Intro Lecture 3. So in this lecture, we're going to talk about the patterns of life. Learning objectives. Identify characteristics of all living things. Explain how fields of biology differ in their approaches. Explain the importance of the metric system. Characteristics of living things. So all living things share basic characteristics. Three of the basic characteristics are they are made up of cells, either one or more cells. Okay, so we are made up of a ton of cells, billions of cells. Okay, living things reproduce. Both for us, we reproduce as a species through sexual reproduction, but we are also able to reproduce and repair our individual cells in the case of like a cut or a broken bone. But they're able to reproduce, and they are all based on a universal genetic code. And that universal genetic code is DNA, or its cousin or sister molecule, I don't know what you want to call it, RNA, which we're going to get into, okay? But those are the three basic characteristics of all living things. They also are able to grow and develop, so you are not the same size you were when you were born. Okay, so we grow and we develop. We respond to our environment. All right, if you put your hand on a hot stove or a hot piece of glass or something like that, okay, you go, ow, that's hot. All right, in the case of sunburn or tanning, okay, that is a response to the environment. We also are able to maintain an internal balance, which is a easier way of saying the fancy word, homeostasis. The internal balance, like your temperature, all right? The average human temperature is 98.6, although there's evidence that it's actually getting lower, but that's a different story, okay? But we are able to maintain that temperature. Different organisms maintain internal balance differently, but we do it with temperature by sweating, okay? Sweating is a way to cool off, or shivering is a way to actually warm your body back up because your muscles actually start to vibrate. And they change over time. That's the process of evolution. Now most of these things all refer to individual organisms. Individual organisms do all of these things. In the case of changing over time, that's the species as a whole. So as fast as that happens depends entirely on how fast a species will reproduce. Bacteria, we can actually see evolution in bacteria in the course of a couple months. Okay, in some species we can see it in a couple years, but for other species it can be generations. It can be hundreds of years before we actually understand or see the evolution. Fields of biology. There are a ton of fields of biology, so whatever you might be interested in. Okay, so global ecology, environmental work. Right? This is actually where I started my career when I got out of college. All right, working in the environment. So there's all sorts of different branches of that. Each one of these categories has its own million sub-branches. Depending on if you're interested in anything that has to do in the natural world, whether it's medicine, technology, any of that kind of stuff, you can find something. Okay? Then we have microbiology, immunology, and molecular biology is where we're actually looking at genes, okay, and seeing how genes code for things, or how different people with differences can, so one of the things that's been going on, especially with the COVID outbreak, is trying to understand why there's such a wide variety of symptoms and why there's such a wide variety of effect, to the point of some people being really dramatically affected by it and some people not even knowing that they have it, and trying to understand the genes or the molecular biology behind that. Scientific measurement. We scientists talk about everything in the metric system. Why? Because it's easy. I know it doesn't sound easy. I know you guys a lot of times it feels hard because we're not used to it, but it's, can you multiply and divide by 10? Because if you can multiply and divide by 10, you can actually move around the metric system super easily, as opposed to like 12 inches equals 1 foot, 3 feet equals a yard, and then however many yards equals a mile. Okay. Yeah, like I don't even know. Why? Because it's complicated. But if you are if you run, okay, and you do a 5K is 5 kilometers, all right? So a 5K, the K stands for kilometers, so it's 5 kilometers, which just equals 5,000 meters. Done. Okay? All right, and then 5,000 meters equals whatever that is, like 50,000 millimeters. Okay, so so it's just multiples of 10. So it's really easy. The only one that gets a little confusing when we're is temperature, because it's, you know, temperature is temperature. There's no real like change, but everything else, it's a multiple of 10. It's really great. So the nice thing, whoops. So the nice thing about, whoops, let me erase that, okay, is that if you look at these, okay, these problems, a 0.45 liters is going to be how many milliliters? Where are we? Here we go. Okay, so 1 liter, okay, is going to equal 1,000 milliliters. So all we have to do, all right, is move the decimal place 1, 2, 3, because we've got 3 zeros. 1, 2, 3. So 450 milliliters. That's it. Okay, 1 kilometer, right, and that actually that one gives it to you. But again, 1 kilometer is 1,000 meters. So if we think about 1 kilometer as being 1.0, all we have to do is move the decimal place again 3 spots, 2, 3, all right, to make it 1,000. Okay. So the thing is, if you're going from a bigger unit, so a kilometer to a meter, so the kilometer is the larger unit, you're going to multiply by however many, you're going to make the number bigger. If you're going from a smaller unit, milligrams, which is over here, okay, milligrams, okay, to grams, you're going to divide, which means we're going to move the decimal place back. So we're going to go from a bigger number to a smaller number. So 1,000 milligrams equals 1 gram. So that's 3. So we're going to move the decimal place back this way. 1, 2, 3, to give you 5 grams. Okay? So now try the other 3. All right? If you need to, you can pause the video. Okay? I'll give you a minute or two. So hopefully you got the right answers. So yeah, when it comes to the excuse me, when it comes to the metric system, you just either have to go up or down the steps, and you either multiply or divide by 10. Every single step is a 10. Okay? So if we were to go from kilo down to the meter or whatever, all right, that's 3 steps, excuse me. 1, 2, 3. So that's a 10 with a 10 with a 10. So if we're going down the steps, we're going to multiply by 10 to the third, aka 1,000. All right. Okay. And the reverse going up. Okay. We'll just divide by 10 to the third, which is 1,000. All right. That's it. Have a great day. Bye.